Hi, in this video we're going to talk about addition formulae in trigonometry. Basically we have 6 formulae for 3 trigonometric functions which are all in here. Now, these look frightening, but there are things that you can use to keep them in mind. So for example, for sine, obviously it's a mixture of sine and cosine in all the terms, plus you see that whatever the sign is here is the same sign. So for sine A minus B, it is a minus sign here. And you can see that if it is sine A here, then it is sine B here, whereas if it is cosine B here, then it's cosine A here. And also notice that it goes like A, B, A, B, right? So it's sine A cosine B and cosine A sine B, right? So if it is plus here, it is plus here, minus here, sine is a mixture. Whereas cosine, it's not a mixture. It's always cosines first, sines later. And it is like cosine A cosine B, sine A sine B. And for cosine, the sign changes. If it is a plus in here, then you have a minus here. If it's a minus in here, you have a plus in here. Whereas in tangent, you can see that there's a fraction here. But again, the signs are the same, but different here. You can see that it's minus, the same, but different here. And it is always a product of tangent A and tangent B in the denominator. So it's either 1 minus tangent A tangent B or 1 plus tangent A tangent B. And at the top, it's always tangent A plus tangent B or tangent A minus tangent B. So once you start using them for a few times, it's going to start sticking to your mind. So we use these addition formulae while simplifying expressions or solving equations, as well as proving identities. Let's start with a proof example. So we're going to prove that the left-hand side is equivalent to the right-hand side. So we can only equate the denominators at this point. So in the numerator, we're going to get cosine A cosine B minus sine A sine B. And in the denominator, it's going to be sine B cosine B. And we know from here, this identity, that the numerator is nothing but cosine A plus B over sine B cosine B. Now let's try to show how we get this formula from this one. So if we use the cosine A plus B expansion, but just substitute negative b for b, we're going to get the following. Cosine A times cosine negative b minus sine A times sine of negative b. Now, in the left-hand side, it's going to turn into cosine A minus b, as we know. But for the left-hand side, we have to use unit circle. Now, cosine minus b is going to be here, and you can see that cosine b is the same. So this is the angle b, this is the angle minus b if you go clockwise, right? The cosine values are the same, so this suggests that cosine negative b is the same as cosine b. So I can write cosine b for this expression. So let's do that. That's equal to cosine A cosine b. Now, for sine b and minus b, you can see that while sine minus b is a negative value, sine b is a positive value. So this suggests that sine of negative b is the same as minus sine b. So the numeric values are the same when you take the absolute value. However, there's a sign difference. So this means I can write the second term as minus sine A times minus sine B instead of sine of minus B. Of course, if I take the minus sign together with these, I have to rewrite it as cosine times cosine B Minus and minus makes plus sine A times sine B. So this is how we get the formula for the difference of angles in cosine. Similarly, every addition formula which includes this difference can be derived from the actual addition formulae. Now let's look at this example. Show that sine 15 is root 6 minus root 2 over 4. Now, this is easy to calculate, there is no problem with that, but we have to show here that sine 15 is actually this exact value. Now, at this point you should know that there are some special angles with special values when it comes to sine, cosine and tangent. So look at this table now. So sine 0 is 0, 30 is 1 over 2, that's root 2 over 2, that is root 3 over 2, and sine 90 is 1. Now this row repeats itself for cosine, but from backwards, so it is 1, root 3 over 2, root 2 over 2, 1 over 2 and 0, whereas for the tangent you just divide sine by cosine. 0 over 1 is 0, 1 over 2 divided by root 3 over 2 is root 3 over 3 after rationalizing the denominator. These two values are the same, so if you divide them you get 1. Here tangent will be root 3, and for 90 degrees tangent is undefined as you cannot divide anything by 0. Now, you may not know these values, but you should be aware that these are specific. And you can use these angles and its trigonometric ratio values to calculate something like sine 15 without using your calculator. Certainly, this is not going to be asked in the exam. You are allowed to use your calculator. However, you have to figure out how you will end up with this. So, for example, you can use 45 and 30 to end up with 15. So you can say that this is going to be sine 45 minus 30, which is equal to sine 45, the first angle, so cosine must be the second angle. Now the sine is the same. Now I used sine 45. It's going to be cosine's turn, so it's going to be cosine 45 and then sine 30. Now, at this point, I can just calculate. I can write root 2 over 2 for sine 45 times cosine 30 is root 3 over 2 minus cosine 45 is root 2 over 2, whereas sine 30 is 1 over 2. And if you do the simplification, you end up with root 6 minus root 2 over 4. So this is how you show the work. Again, you don't need to know the table, but it will help you to just go quickly on the solution of it. You can always use a calculator to end up with these values. Another example. Now in this one we are given the value of sine A and cosine B, and we know where the angles A and B are. Well, this is important because this is how we're going to decide the sign of these values, right? So let's find out cosine A minus B, tangent A plus B, and cosecant A minus B. So let's start with the first one. Cosine A minus B means cosine A times cosine B plus, because this is minus, sine A times sine B. Now, we know sine A, but we don't know cosine A. We know cosine B, but we don't know sine B. So for these two, I need to draw two triangles. So first, let's find cosine A. Now, the angle A will be here. And according to sine A being minus 3 over 5, of course, I'm going to consider it as 3 and 5 here, because I know sine is opposite over hypotenuse, right? I'm ignoring the sign there, because I'm now considering A to be in the first quadrant. Now, to find cosine A, I need to calculate this side length. So it's going to be x squared plus 3 squared equals 5 squared. It's Pythagoras, and x will be 4. So cosine A will be 4 over 5. Now, I'm going to look at the unit circle to figure out what cosine A actually is in terms of sines, because the angle A is in the third quadrant. So it's actually here, right? So in the third quadrant, cosine is negative. So this actually should be cosine A equals minus 4/5. Now that I'm going to be calculating tangent 2, I'm going to calculate tangent A as well. But tangent A will be 3/4. And in the third quadrant, tangent is positive because here both sine and cosine both are negative. So negative divided by negative is positive. So let's write these quickly and then move on to angle B. Now, B is here and this is 90 degrees here. And I know that cosine B is minus 12/13. So it's adjacent over hypotenuse. So I should be writing 12 and 13 like this, ignoring the sign. And now I have to find the value of x, which is 5 here. So now I can write sine B to be 5/13. Now I know that angle B is obtuse, so it must be somewhere here. And I know that the sine value is positive here, so sine B is positive. Whereas for tangent B, which would be 5/12, it is going to be negative because although sine is positive, cosine is negative. So sine over cosine, which is tangent, will be negative. So tangent B actually is minus 5/12. Let's write these down as well. As you can see, with the help of trigonometric ratios and Pythagoras, I was able to calculate those values. So all I need to do is to substitute them. So it's going to be cosine A minus 4/5, and cosine B is given minus 12/13, plus sine A is given minus 3/5, and sine B is 5/13. If I do the calculations, I'll get 33/65 for cosine A minus B. When it comes to tangent A plus B, let's write the expression. It's going to be tangent A plus tangent B over 1 minus tangent A tangent B. Let's substitute the values. So it's going to be 3/4 plus minus 5/12 over 1 minus 3/4 times minus 5/12. And I'm going to get 16/63 as the answer for tangent A plus B. And for the third one, cosecant A minus B is nothing but 1/sine A minus B. So I should be writing 1/sine A cosine B minus cosine A sine B. So it's going to be, if I write all these values like this, and if you simplify, you will get 1/56/65, and if you flip it over, it's going to be 65/56 as the final answer. As you can see, the tricky part is to find the unknown trigonometric ratios by using Pythagoras and right triangles, because you may make sign mistakes, but other than that, it's just substitution and finding the values. Now is your turn. Please solve these exercises on your book and submit your answers online. Thanks for watching.